it's an amazing process. Just what goes on, even inside your headphones, the circuit boards, the circuitry, how that's all converted from power to very minute power to digital inputs and outputs. So again, like I said, I was watching Miss Andrea kind of do the math on some of these binary language things, and it's just unbelievable. So you're going to get a lot out of this class, a lot of information. We don't expect you to be a superstar unless you really want to excel in it. But again, take what you can from it. If you have questions, make sure you ask, okay? It doesn't hurt to ask, especially when you get into the circuit boards, the resistors, transistors, the Ohm's law, and all that different kinds of things. So anyway, with that, I'm going to turn it over to Miss Andrea.
All righty. So, again, if you want to turn your cameras off, I'm okay with it. I just prefer them on. No worries. Okay, so first thing, I'm going to share the screen so we can get started on the electronics merit badge. Yeah, Ranger Anthony and I actually just finished the electricity merit badge, and it was pretty cool. I learned a lot, honestly. All right, so this is the electronics merit badge. And like I said, I'm going to be going over the workbook. Make sure you have it on hand so that you can fill it in if you haven't already. All right, requirement number 1, it said to describe the safety precautions you must exercise when using, building, altering, or repairing electronic devices. Now, when you do this in person on Saturday, or, I know there's a couple of you that might not make it Saturday and you're going to do it at a later date, that's perfectly fine. But when you do it in person, you'll get a lot of this safety stuff. You're going to have all the tools in front of you. You're going to have the safety equipment, and you'll talk about it. But just for you to write down on your workbook, you can write examples like you got to have basic tools, the screwdriver, that's flathead and Phillips, your nut drivers, your pliers, your long nose pliers, a wire stripper, a magnifier, because when you're working with transistors and stuff, some of them are really tiny and you have to fit into a specific spot. Safety equipment, goggles, scouts always wear goggles. You want to be careful with electrostatic discharge, which is, your static electricity. And you obviously don't ever want to force the components into a space. Like if you think it goes here and you're like, I'm pretty sure it goes here, and you try to force it into something, don't ever do that with electronics. You can break and hurt every little part is worth a lot of money. So you never want to force your components or even over tighten the screws. Don't think, oh, it's gonna fall out. No, don't ever over tighten your screws, okay? So that's basic stuff. Like I said, you're gonna go over more of that when you're in person doing your projects. So requirement number 2, it said to draw a simple schematic diagram, okay? It does have to show your resistors, your transistors, your capacitors, and you have to have the correct symbol. This is an example. I actually got it off of Google. Just drawing something simple. There's a lot of them in the book, and you can, copy some of them in the book, but just to know how to draw that and how to show, how they all work together, okay? So you're just gonna draw one of those onto your little diagram here that you have and bring that with you on Saturday to show the counselor, okay? And the next page, it's asking you to tell the purpose of each of those parts, okay? I just wrote basic information that I found in the merit badge pamphlet. Your resistors have a specific amount of resistance, okay? And it controls the electric current. Capacitor, you think of the capacity, right? Capacitor, it's a storage element, okay? Now, the resistor, I remember the resistor, it's like, if you're thinking of a hose and you spray a sprayer on the hose, if you just pull back a little bit, just a little bit of water goes out, right? But if you fully pull that handle, you're getting a lot of water out. So resistor is that handle. How hard you pull it or how light you pull it. It's going to control the water current, right? Capacitor is more like a water bottle. It stores all the water in there. So it's a storage element for that electric charge. And they can come in all different sizes. It depends on what voltage rating the capacitor is. Your transistor, it says it's a semiconductor device. It's used to amplify or switch the electronic signals and electronic power. Usually there's 3 terminals, at least 3, okay? The integrated circuit, that's your little small chip that can function, it can function as an amplifier, a timer, every little part in your computer. You guys are on a computer right now. So if you opened your computer up and look, there's a whole bunch of little microprocessors on there, okay? And your computer memory obviously is a circuit. And it says other on there, but the counselor can go over any other parts he thinks you should know. Any questions so far? We're good? All right. For requirement number 3, this one's all about soldering and desoldering. I'm not even gonna go over it because I honestly just know how to do it. I don't know how to talk about it. You will be doing that. You'll be soldering a little circuit board thing on Saturday or when you do the in-person part of it, okay? So you're definitely gonna discuss it with the counselor. Okay, so I'm gonna skip that part. Requirement number 4, you're supposed to discuss each of the following, okay? And it says how to use electronics for a control purpose, okay? This one, a control purpose, thinking a switch on, off, but on a timer, okay? So this one is like if you have a alarm clock, okay? It's on a timer. Or your watch. I have an Apple Watch, right? And I have my alarm clock on here, and what it does is it vibrates and shakes my arm and tells me when to wake up in the morning. That's a control purpose. Okay, when you go to a grocery store, most of the time, especially now, all grocery stores' doors will open automatically as you get closer to the door, right? There's like a control pad. When you step in a certain place at that doorway, it's going to open the doors. That's a control purpose. That's an electronics control purpose, okay? Number 2, it says the basic principles of digital techniques. Obviously, that's like I said, computers, calculators, things like that. It's circuits and processors. It's a calculator. You put the numbers in, and it feeds you out an answer, right? So that's a digital technique. You put information in a computer, or you install a software program, and you use your mouse, and you tell it what to do. That's a digital technique, okay? How to use electronics for 3 different audio applications. The 3 applications that were mentioned in the pamphlet, hi-fi stereo field, which is, your stereo, your DVD, things like that. The spoken word on that one, we're talking about electronics, right? Thinking of a public address system, meaning a speaker. When you go into the store and you hear over the intercom, or even when you were going to school in person, they would make announcements over the intercom. That is an audio application of electronics, okay? And then musical instruments, we're talking about electric guitars, electric keyboards, any kind of electronic musical device. Okay, so that was all number 4. Okay, let's go down. Oh, now, this one is the fun part. If you like me and you like math, this next part on page 4 of your workbook, it says to show how to change 3 decimal numbers into binary numbers and 3 binary numbers into decimal numbers. I actually found these really easy to understand YouTube videos, okay? They're each 12 minutes long, so I'm not going to play them, But when I get the PowerPoint email to your parents, ask them for the email so you can go find these links. Okay, so you'll just be able, on the PowerPoint, you should be able to click on it. In fact, what I'll do is when I email this PowerPoint to your parents, I will include the links to those YouTube videos. They're really easy to understand. It's also in the book, exactly how to do it. And I will be there Saturday, and I won't have a class at the same time as yours. So I will come over to the class and I'll demonstrate on a whiteboard how to do this. Okay, so it's very hard to do over a Zoom. But I do have these 2 videos that are really cool. Okay, so I'm gonna skip those, but you definitely need to know, because in electronic, it's definitely important to know how to change binary numbers to decimal numbers and vice versa. Okay, requirement 5, you're supposed to show and solve a simple problem involving current, voltage, and resistance. Obviously, that's all the Ohm's law. Okay, so as it shows here on the screen, Ohm's law says voltage equals resistance times current. Now, if you take an algebra, which most of you probably have at least got into some algebra by now, this equation, you can solve it for any of those letters, which is what I did here. So if V equals R times I, then I equals V divided by R, or R equals V divided by I, by just using the one that they gave you, where R equals resistance, V equals voltage, and the I equals the current. Okay, so that right there is the equation that can help you find out any of those 3 parts. Okay, and over here on the side here, there's a basic diagram that shows you where the resistance is, where the current is flowing, and the voltage. Sorry, the voltage. All right, so there's a basic, because they asked you for a simple problem, so I found a simple problem. It says find the current, which is I, through a resistor of resistance R, being 2 omega, if the voltage across the resistor is 6 volts. Doesn't make any sense really if you're not an electrician, but what you're going to do is take this equation, you're going to substitute resistance, they told you was 2, so you're going to put the 2 in for R. They said that the voltage is 6V for 6 volts, so you're going to put a 6 in for the V. Okay, so in Ohm's law, V equals R, you're putting that in. Then we're looking for I, because they asked you to find the current I. Okay, so based off of that equation, I equals V divided by R. So it's I equals V, which was 6, divided by R, which is 2. 6 divided by 2 is 3. So the answer is 3 amps. It's that simple. Okay, so don't make it more difficult. It's really simple. You're just substituting the numbers given into the equation to find the missing number. Okay? Any questions on that? We're good? Awesome. All right. The other part of number 5, for 5B, it says, why do you need test equipment in electronics? Well, you need to measure the current, the voltage, and the resistance, okay? If something goes wrong with your computer, sometimes we're like, I have no clue what's wrong with it. Or say my radio stopped working. Most of the time, most people throw it away and get a new one, right? But if you are really wanting to find out what's wrong with it, you need certain test equipment, okay? Some of the types of equipment, I asked you to name 3 types of equipment and how they operate. Well, there's a few here. Meters. You got a digital meter, an analog meter, and an ammeter. All of those are in your book again. They all measure the current, okay? The voltmeter, again, obviously that's gonna measure the voltage, okay? Your ammeter, it's gonna measure the resistance. And then obviously a multimeter, multi means more than one, right? Well, the multimeter is gonna measure all 3 of those, the current, the voltage, and the resistance. So which one do you think is the most handy to have? The multimeter, right? Yeah. because it measures everything. Okay? So those are just certain 3 types or 4 types of test equipment and how they're used. And they are all illustrated in your book. You know, you can get this book on Amazon and stuff too, a digital version. But yeah, look at through those. The council will have several of those on hand Saturday, so you can actually see how they work. They're really cool. Awesome. Okay, that was number 5. Number 6, you're supposed to find out about 3 career opportunities in electronics that interest you, okay? And discuss the training and education needed for each. So this, you have to pick 3, then you got to find the training and education of all 3. In the book, it mentions there's several areas that include manufacturing, merchandising, operating, servicing or maintaining, and engineering electronic parts and equipment. So electrical engineers and stuff like that. Now, if you think about it, electronics, a career in electronics, computers, right? Everybody has to have a computer, especially right now. There have to be those people that have a career on how to fix computers, okay? There's electronics in everything. Like I said, if something you have is electronic, you know, it goes by battery, it goes by AC or DC. We learned about that, and electricity. So any of those things, somebody that's skilled in electronics knows how to use those multimeters, and they're gonna figure out what's wrong with it. Is it the resistance? Is it the voltage? You know, maybe you're not using the right voltage, or, you know, the amps that are coming in and out, flowing, they're not high enough, something like that. So there's all kinds of areas, career opportunities that you can explore in electronics. Just Google it, you know, careers in electronics. There's gonna be all kinds of them. Again, manufacturing is actually building parts. And like I said, there's gonna be a need for electronic parts forever. Okay, merchandising, that's actually making sure you have those parts available and being able to tell someone what part they need and sell them the right one. Okay, operating it, there's going to be people that do not know how to use certain electronic devices, so you have to be able to show them how to use them. So basically, you be an educator or a trainer, showing them how to operate the device. Okay. And yeah, so, you know, this merit badge, it's really quick, but most of it is in person. It's that hands-on building, that, you know, soldering and desoldering, building a project and things like that. All right. So are there any questions at all? None?
So we bring the packet on Saturday, right?
I'm sorry? Yes, please do that. That way the counselor can see your diagrams and your education stuff. Yeah, so bring that with you. Obviously, if you forget it, just make sure you know the answers so that if he asks you the question, you'll be able to answer it, okay? But again, the fun stuff is in person. You know, I'm boring, but the fun stuff, actually building these things, is a lot of fun. You want to wear a activity uniform. You don't have to wear your Class A. Activity uniform would be sufficient, okay? Your Class B shirt. You don't have to wear jeans if it's gonna be hot. I don't think jeans are really important. You can wear jeans or shorts, that's fine. You wanna bring water to have. You wanna bring your face mask, okay? You will be given a light lunch at the end. I have some like granola bars and things like that. You'll be given that when you leave. Other than that, does anybody have any questions about Saturday or about the merit badge itself? Yeah, go ahead.
I have a question.
Sure.
Oh, sorry. Is this all needed to be filled out by Saturday?
Need to be all filled out by Saturday.
And that would be the best thing to do. I just gave you all the answers. I'm going to send this PowerPoint to your parents, okay? And you can go back and watch it and fill it all in, okay? Like I said, I can't tell you, you must have this in hand. I would prefer you do, because like I said, the counselor is gonna go over it again. I just basically just gave you the answers, okay? And allowed you to ask questions. All right? Nathan, did you have something?
Yeah, do we need to bring a blue card?
Okay, for blue cards, an actual blue card, great. I'll make sure it gets signed. If you have digital blue cards, that's fine too. It's best if you print something out, like a digital blue card's fine. I can sign it, or the counselor can, and you can send that back to your scoutmaster. Okay, not a problem. Perfect. Any other questions? We're good? Awesome. All right. No questions? No nothing? Okay, so I have 2, 4, 6. All right, 6 of you. All right, is anyone not coming Saturday? I know Addison can't make it. The rest of you are coming, right? Billy, are you going to be there Saturday? Awesome. All right. All right, I expect all of you. Okay, no problem. All right, if you have no questions, you're free to go.
Thank you.
Thank
You're
you so
welcome.
much.
Thank you.
Have a great
See
night.
you.